Hi everyone, this is Eric from Dumb Game Dev, and today this is, I guess, day 4 on 30 custom Playmaker actions for 30 days. And today we're going to be talking about... What are we talking about? We're talking about the Random Float Exclusion. Now, this was a request on the Playmaker forum, so I picked it up, Googled some different possible solutions. There was one from Stack Exchange that I made a couple of changes to and made it to a Playmaker action. Unfortunately, there were still some errors, so Gene from Playmaker helped out and made a couple more corrections. So this is sort of a team effort between a couple of people. And what it was originally being used for in the post, I believe, was a random tree generator that would generate trees that wasn't on a path, so in the different area. As you can see on the screen here, I've got 2 planes, and one is the grass plane, and one is for the road. So what this action is going to do, or how I'm going to show you to use it, is to generate trees randomly. Now, if you were doing a runner or some type of game like this where you need to generate random trees or different kinds of objects, doesn't have to be trees, but you want it to only appear in certain places, this is a good way to do it. Now, I have already set one up, so I'm just going to show you how it works, and then we'll go over making our own. So I'm going to say, for example, set this to 11 loops. This is going to set up 10 trees when I push play. And there you go, so it generated 10 trees and none of them on my path. Now I could even make this higher or lower. I could say generate like 29 trees here. And as you can see, still not on my path. We could even go higher and higher and keep going, and they would never appear on my path because of the way I set it up. Of course, you could even just do like 2 or 3 trees for a more natural look over a larger area. Okay, so let's see how I did this. Now, I already have an FSM set up. I'm going to set up a new one, and we'll just disable this old one so it doesn't run. And to do this, I'm just going to create a new empty game object to hold my FSM. So I'll just call this FSM holder. You could attach this to anything, but I'm just going to do it here. Now, the first state we're going to have is to generate floats. And we can name the state whatever we want, but I'm just going to call it generate floats. And I like to plan out my states before I start putting on my actions. So the next state I'm going to put here is a... What do I even do? I'm going to have a loop counter on the next state. So loop counter. So this is going to count how many trees I'm going to use. And you can use my loop counter. I talked about this in a previous video. Or on the ecosystem, there's another one called iterate, which is a very similar, if not almost the same action as mine. Iterate, or loop counter. You could build your own loop counter, but this is just an easy way to do it. Then the last state is, let's just generate some trees, right? Because we want that to happen. And then at the very end, we need some kind of a finished state for it to go to when it's done, so finished. And the finished state will have nothing on it. So the first state, we want to generate floats. So we're going to generate a float for... Now, I created an empty game object just to help me out here, and I called it marker. And if I move it right and left, and I look up here in the position, it's going to give me the positions I want to use. So I want trees from here to here, and then again from here to here. So my maximum range is, I want, say, from -5 to... We'll say 5 all the way just to make a nice easy number. Okay, so let's go back to our FSM, generate a float, and we're going to use the Random Float Exclusion. So the maximum is 5, and the minimum is -5. Okay, so we want to exclude the road. So let's go back to our little marker here to help us measure. And the road is sort of about, let's say, -2 to about 1. So -2 to 1 is the area we want to exclude. So minimum is -2 and 1. Okay, so we want to store this into a variable, and I'm going to call this float. So this is the x, so it's the float x. Now, I don't want my trees to only appear on a line on this x. I want it also to move on a z-axis. So let's also set up a z. But we don't need to exclude anything on the z-axis, so we can just use a regular random float generator. So let's just choose random float. and I'm going to generate this random float. Let's see here. Measure this out between, say, like 1 to, let's say -8. 1 to -8. So here we need this from, the minimum is 1, or I guess the minimum is -8, oops, to 1. So we're going to store this in a variable, and we're going to call this float z. Now, as far as the y-axis, I'm going to set this to be static because I don't need it to be higher or lower. I want it to be all the same. I'm just going to set mine to 0, to be honest. Okay, so once the floats are generated, it's going to be finished. And we'll go to the next state. And this is the loop counter. We want to count how many times this is going to happen, how many times we generate these floats. We want this to keep going. So I'm going to search for loop, or you can use iterate from the ecosystem. Simple loop counter. Now, say the max we want to count off is 10 loops. The current loop is 0. We want to count 1 loop at a time. When it is finished, we're going to add a finish state, and this will go all the way over here to this finished one. So once it's done, it'll go there. We want it to stop. And the loop continue event, we want it to keep going. We'll just say keep counting. You can call this whatever you want. And we'll use this for both these. Keep counting, keep counting. So keep counting will generate more trees. Okay, so to generate trees, we are going to use a, let's see here, a create object. So this is going to use something from a prefab. So we'll create the object, and the game object I want is some kind of tree. So let's search here, tree, big tree I'll use. And we're not going to use a spawn point, we're going to use a position. Now, the position only takes a variable for vector 3. So let's just call this vector 3 position. So we know we need to get a vector 3 position, and we've got an x. What do we have? An x and a z. So we have to make our own variable, or our own vector 3 variable. So we're going to use this one called set vector 3 xyz. So we'll do this just before we create our object, and we want to store it in a variable called vector 3 position. The x, we want to give it the float x. The z, we want to give it the float z. And for the y position, we just want it to be on the ground, so I'm just going to have it as 0. So then once this is done, we need to add a finish state, so it's done. And go back to generate more floats. So this is kind of an ugly circle here, but let's give it a try and then sort of see what happens, and maybe I made some errors, I'm not sure. No, looks like it was okay. So we just do it a couple of times. So sometimes the trees are a little bit too large for this. The middle is probably not on. Okay, so we can change our loop counter to be higher. Like we could set this to 30, and it'll generate 29 trees, I believe. We have to set it 1 over the way it's set up. But as you can see, there's a lot of trees going on. So that's basically how this works. So I'm just going to do a quick review in case you missed something. So the first state is to generate floats. So we want one exclusion float, and we're using on the x-axis because we want to exclude the road here. Then we did another random float, and this was on the z-axis, and we didn't need to exclude anything. It's just up and down here. And we used just a little empty game object, or you could use anything you want, just to find those positions in the inspector. It doesn't actually do anything. It's just to help us visualize, right? Then in the next state, when that's finished, it would count off a loop. So we have a way of counting how many times this is happening and then stopping it when it's done by going to the finished event. So again, I have a tutorial on this loop counter. Go check that out if you need it. Then we generate trees. But before we can generate the tree, we need the vector 3 position. So we have to make a vector 3 variable. We plugged in the float x, the float z, And once that's done, it goes back to the very beginning until the loop counter says no more, goes finish state, and we're done. So that's it. It's fairly simple if you walk through it sort of one step at a time. And these are our sort of bread and butter Playmaker way of doing things for the most part. So you can get this action from my GitHub account, and hopefully soon it will be on the Playmaker ecosystem. Just haven't gotten around to doing that yet, but in the next week or two, we'll make that happen. In the meantime, join us on our Stack chat for Playmaker, and there's again a link in the description for this, and we just have a general Playmaker chat about this and that. It's partially casual and partially work related, so come by, chat, socialize, and talk about Playmaker. Okay, until next time, everyone.